Hello, everyone. How are you doing? I trust you are all doing great. James from JT's Maths Tutoring here. Today, we want to prove the inverse of a 2 by 2 matrix using elementary operations. So let us assume that we have got a matrix A with the entries A, B, C, D. Now, we want to use the elementary operations to prove whether A is invertible or not. Okay, let's get going. To find the inverse of an invertible matrix using operations, we adjoin the identity matrix to the right side of A, thereby producing a partitioned matrix of this form right here. We then apply operations to the partitioned matrix until the left side is reduced to an identity matrix. These operations will convert the right side of that partitioned matrix to be the inverse of that given matrix. Hence, the final matrix is actually going to be of this form. So let's look at the proof. So I have my A right here, and I've adjoined the identity matrix to the right of A. So let's start performing the operations. I want this A here to be a 1, and I want this C to be a 0. I want this B to be a 0, and I want this D to be a 1. Right. Dividing row 1 with A, or multiplying row 1 with 1 over A to give me row 1, this is what I'm going to get right here. I now have my 1 where I want it to be. This becomes a B over A, and this one 1 over A, and I've got a 0 right there. Now I want this C to be a 0. So what I'm going to do is I'm going to multiply row 1 with a scalar negative C, and then add it to row 2. By so doing, I have a 0 right here, and right here I'm going to have AD minus BC over A. I'm going to have minus C over A right here, and I'm going to have a 1 right here. Beautiful. Now I want this part here to be a 1. So how am I going to make this a 1? I'm going to multiply this row 2 with A over AD minus BC. But by so doing, I'm going to have a 1 where I want it to be, right? And this one will change to this one right here. It's going to change to negative C over AD minus BC. This one right here is going to change to A over AD minus BC. Wonderful. So I now want where this B over A here to be a 0. What am I going to do? I'm going to multiply row 2 and add it to row 1, but I'm going to multiply row 2 with negative B over A and then add it to row 1 to get a new row 1. Awesome stuff. By so doing, I've got my 0 where I want it to be. I've got my 1 where I want it to be. Awesome, awesome. They've told me something here that when the left side is now reduced to the identity matrix, the right side is actually the inverse. So it means right here, this is the inverse of that 2 by 2 matrix A with the entries A, B, C, D. Okay, so the inverse is actually that, right? But I've noticed here that I've got a common factor here, AD minus BC, AD minus BC, AD minus BC, AD minus BC. So I can factor 1 over AD minus BC. Boom. Did you see that, Jimmy? You threw that miles away. Beautiful. This is exactly what I wanted. So I've actually proved that as long as AD minus BC is not equal to 0, boom, there is your inverse of a 2 by 2 matrix using elementary operations. Allow me to take my leave right now. Mommy is asking me to come and do the dishes. But until we meet again, be rest assured that at JT's Maths Tutoring, we are committed to keeping you mathematically informed. Don't do what Mama and I wouldn't do. Adios, amigas and amigos.